Introducing the newest member of the Sartorius BioPAT family, the BioPAT Spectro, seamlessly integrating Raman Spectroscopy within our upstream portfolio. The BioPAT Spectro helps you unlock the potential of Raman Spectroscopy to enable quality by design at small scale in amber and at pilot commercial scale in the Biostat STR. During the development process of the BioPAT Spectro, we focused on the needs of single-use commercial manufacturing, and then translated those needs to requirements for process development. Single-use commercial manufacturing requires robust process transition from process development. The process must comply with regulatory requirements, and ideally, a quality by design approach should be applied with deep process knowledge of design space, in order to ensure high product quality and quantity at any given time point. We have identified Raman Spectroscopy to be the perfect tool for QPD, because it is a technology that is able to measure several key analytes simultaneously with a single probe inside the bioreactor and in a non-destructive fashion. We built BioPAT Spectro to remove the common pain points in bringing Raman to commercial manufacturing. For this endeavor, we partnered with two leading providers of Raman spectrometers, Kaiser Optical Systems and Tornado Spectral Systems. Our solution provides integration for both. So, how does the BioPAT Spectro work? Let's take a look at various use cases, starting with spectroscopic model building. With BioPAT Spectro, model building is accelerated through the use of multi-parallel automated bioreactors, Amber 15 and Amber 250. The Raman integration occurs online within the analysis module, affixed to the side of the Amber system. The sampling robots can deliver a sample from the bioreactors. Each sample is dropped into the sampling cup and pumped to the Spectro flow cell, which is in turn connected to the optical probe. Third-party spectrometers are fully and seamlessly integrated into our Amber system. This is highly advantageous because the user must only interface with a single computer to control the spectrometer and collect the spectral data of the Raman measurement. Raman spectra is then scanned within the flow cell. At the same time, the Amber also collects reference data, such as data from other integrated analyzers, the Viscel and the NovaFlex 2 analyzer. The user may also manually add at-line of offline analysis results into the Amber software. Finally, the process data from the different vessels are collected and included within the dataset. The Amber not only collects this data, but also contextualizes it by aligning all the data from the different vessels and organizing it into a data file ready for model building to be used within the multivariate data analysis software SIMCA. SIMCA is then used to build models which can accurately predict the analyte concentration from the spectral data in real time. Now, let me summarize why model building in Amber is faster, cheaper, and better than ever possible before. We have a fully automated data acquisition and contextualization that provides a data file ready for model building and can be executed by operators who may be untrained in Raman spectroscopy. Due to the multi-parallel application of up to 24 bioreactors in Amber 250 and up to 48 bioreactors in Amber 15, one Amber run is sufficient for model building and to execute a full design of experiment. More than 600 data points can be generated in one Amber run, and with one operator. A rich dataset that includes all the available process data for the robust model building. Additionally, we added automated spiking of pure analytes to the system, which helps break correlation and build models based on causation rather than random correlations, without interfering with the process. The second use case is the application of Raman for process development. You can now apply Raman spectroscopy for monitoring and control in high-throughput process development via the AMBER system. The AMBER is able to predict the analyte concentration from the spectral information in real time. The model file from SIMCA is downloaded into the AMBER computer. The computer is able to read the model and predict the analyte concentration from the spectral data in real time. You can then use the analyte concentration for process monitoring and control. We offer a fully automated and integrated use of Raman spectroscopy. You can now apply this technology in high-throughput process development to increase your process insights, and can apply that knowledge for quality by design. The advantages for process development are fully automated Raman spectroscopy, high-throughput process development, and increased process insight. Let's now move to the third use case, which is the application in single-use manufacturing. With BioPAT Spectro, we have a ready-to-use, fully integrated single-use solution, and we facilitate the scalability of models from the AMBER. In the STR, we integrated a single-use port into the stirred tank bag. The impellers stir the cell culture solution and push it through the flow cell of the single-use port integrated in the bag wall. The flow cell configuration isolates the sample from process conditions such as stir speed or bubbles, and very importantly protects the measurement from stray light. This increases the signal-to-noise ratio. The single-use integration allows for a faster setup time. Here you see how the liquid is flowing through the flow cell, where Raman spectroscopy is measured. Let's take a look at the spectroscopy integration for the BioStat STR. A specially designed spectrometer probe is attached to the BioPAT Spectro port on the STR bag. This probe is then connected to the spectrometer via fiber optic cables, where the raw spectral data can be applied to the predictive models and visualizations from the spectrometer software. It is also possible to integrate the spectrometer output with the bioreactor SCADA or plant DCS software to implement data logging or process control. For both the AMBER and BioStat STR, the optical design of both spectro flow cells are identical. This means that the same fiber optical probe can be used. This smart design enables more seamless transfer of Raman models from PD to manufacturing. The BioPAT Spectro is a scalable platform approach from the AMBER 15 and 250 to the BioStat STR 50-litre through 2000-litre. So coming back to our initial requirements for commercial manufacturing: efficient process transfer, regulatory compliance, and quality by design. BioPAT Spectro satisfies all these requirements, as we have a single-use port in the STR that is fully qualified for GMP use. We have a scalable platform from 15 milliliters to 2000 liters, and we enable quality by design by building robust models for several analytes in the AMBER and by easily transferring them to the STR for commercial manufacturing.